Howdy AP Pre-Cal, it's Miss Kosh. I am back for more multiple choice problems. This is Unit 1 from Mr. Passwater. Go see my previous videos and my notes. I probably will not send you this PDF, so sorry. And I'm not doing everything. I think I did something similar to this in this last one. So we'll jump down. I'm just gonna see how many of these I can do and how much I can help y'all and that kind of stuff. So let's look at, I don't think I've solved one quite like this. Okay, so they give us this rational function and it says when we get close to 1, where x is greater than 1. Okay, so this is fun. So what's happening here is that we've got this rational function. We have an asymptote at positive 1. We have an asymptote, the leading coefficient is negative 2 over 1, so we have an asymptote at negative 2. And then I can say, well, let's see. So we want to know what's happening when x is bigger than 1, but getting closer to 1. So because there's nothing else, and this could have been written as negative 2x minus 6 over x minus 1. Okay. There's nothing else weird happening in this problem. When they look something like this, you do have some weird, you have holes, you have like squiggly stuff, you have multiple vertical asymptotes. This one is pretty straightforward. You've got a horizontal, you've got a vertical, and we can just kind of see what's happening. So what I would probably do is say, okay, well, what's f of 2? If I can find f of 2, then that'll tell me if I'm up here and go off to positive infinity, or if I'm down here going down to, oh, you couldn't see what I was doing. If I'm up, if f of 2 is somewhere in here, then I know that I'm going to go off to positive infinity. And if f of 2 is somewhere down here, that's what I would have done, then it would have gone down to negative infinity. Okay, so let's see, let's plug in 2. I'll plug it in here. This gives me negative 4 minus 6 is negative 10 over 2 minus 1 is 1. So negative 10, so we're way down here. So that tells me that the graph is going to do something like that. Another way to think about this is that I could take this equation and do synthetic division by dividing the 0 here. So this is negative 2 times 1 is negative 2, and this gives me a negative 8. So basically what I can tell you here is that f of x can be rewritten as negative 8 plus, I lied. It can be rewritten as this, negative 2, plus the remainder of negative 8 over what we're redividing by, x minus 1. So if you think about it, I've enjoyed teaching it this way for the last few years. Basically, what this is telling us is it took my original graph, it took the graph y equals 1 over x, okay, and it reflected it and stretched it. So y equals 1 over x would be here and here-ish. That's bad, but whatever. And then, but it reflected it, so now we have moved, this has moved down here, and this has moved up there. And then we stretched it. And then we shifted it to the right 1 and down 2. Okay, and so that tells me that I'm going to have my curve down here. So that's another way to think about it. So let's see, the output values, so let's see, which of the following describes the output values as the input values get arbitrarily close to 1 where x is greater than 1? The output values decrease without bound. Yep, I think so. The output values increase? Nope. The output values get arbitrarily close to negative 8? Nope. And they get close, no, so I was right, it's the very first one. Okay, a rational function is given by this. What is the limit statement? As we're approaching, oh, these are good. We want to approach an asymptote, so that we have this asymptote at x equals negative 3. So let's not look at the 2, because this is just a 0. If k of 2, it's going to be 2 minus 2 is 0, is just 0. So that's interesting, but it's not going to go off to infinity. So when I approach, this is saying when I approach negative 3 from the right-hand side, well, so let's see. This one, once again, negative 1, 2, 3, we went down, I lied. Sorry. We have an asymptote at x equals negative 3. And then divide our leading coefficients, and I get an asymptote at y equals 1. And so now if I plug in 0, this is one way to do it. I'm going to have the point 0, comma, negative 2/3. So 0, negative 2/3. Well, this was at 1, so, oh, negative is down, not up. It's Friday afternoon in April, and I'm tired. So, okay, so it's going to be looking, or what another thing we could do is we know we have a 0 at 2. Okay, so it's doing this sort of thing. So what is it doing as it approaches negative 3 from the right? It goes to negative infinity. Those are fun. I was serious, but okay, the next few look pretty similar. So I may skip those. Let's look to this one. The rational function is given by this. Which of the following statements about R is true? Okay, so this right here shows me that we have a hole. We have a hole when x is equal to negative 4. And then if I plug in negative 4 to the original, to what's remaining when I take that out, the x value becomes negative 6 over negative 2, which is a positive 3, I think. Okay, input values of R sufficiently close to negative 4. That's good. We agree with that. Correspond to the output values arbitrarily close to 0. No, I think it's to that positive 3. So basically what they're saying is as we get our graph, here's what's happening. Our graph has an asymptote at x equals negative 2 and y equals 1, same reason as the last problem. We have a hole at negative 4, 1, 2, 3, 4, positive 3, 1, 2, 3. We have a hole right here. So what we're doing is we're getting, and then, I don't care, something's happening over here like this. But as we get closer and closer to negative 4, we're getting closer and closer to the y value of that hole, which was, well, let me make sure that I didn't lie to you. We're plugging in negative 4 to this, the part of the equation that's left. Negative 4 minus 2 over negative 4 plus 2, negative 6 over negative 2. I was right, it is 3. Okay. You get tired, you make mistakes. There we go. There's that one. Let's see. This next one seems to be pretty similar. I may skip that one. It has a hole, which the following, if it has a hole, then it has to have the same thing on the top and the bottom. This would have a hole and it would be a 0. This one would not, this is clever. Okay, so this is not a hole, it's on the top. It can't be, and it's not on the bottom. So that's no good. This is on the bottom, but it didn't cancel with something on the top. So this is x equals 1 as an asymptote, not a hole. So now we're going to compare these two. Well, what happens is that this one looks like the graph y equals 1 over x minus 1. Well, what happens in the graph y equals 1 over x minus 1? We have an asymptote at x equals 1. So the asymptote trumps the potential of it being a hole. This one, however, would look like y is equal to x minus 1 over x minus 4. And so there was no asymptote at x equals 1, so this is the one that has a hole. It has a hole, and it is known that the limit as it approaches the hole is 4. Okay, so basically, we need to have an x plus 3 on top and bottom. I don't, right, because there's a hole at x equals negative 3. So there's no x plus 3. There's no x plus 3. Okay, so we've narrowed it down to these two. And now if I plug in, so if I remove everything else, this is going to look like, the x plus 3's cancel, x minus 4 over x minus 1. And this is going to look like, but it has a hole. It's going to look like x minus 5 over x plus 1. So we want to know what happens when I plug in negative 3. When I plug in negative 3, I have, negative 3, this becomes a negative 4, which will cancel with this 4, making the whole thing negative, and negative 3 is a negative. So this is going to have, this is going to give us a hole at negative 3, comma, I think it was a 7. But they wanted it to approach 4, so I think that this can't be right. Let's check this one. If I plug in negative 3, I have negative 3 minus 5 over negative 3 plus 1. This is negative 8 over negative 2. Can you see what I'm doing? And this is a positive 4. So this has a hole at negative 3, comma 4, which tells me that the limit as I approach the hole is going to equal the y value when I plug in. Anyway, yes, this is correct right here. Hopefully that made sense to you. If not, let me know. Okay, so the next one, those seem pretty similar. If it has an asymptote and a hole, the hole is going to cancel and not leave me with an asymptote. So, so this one might be okay. Does it have? But it doesn't have an asymptote at 1. So the x plus 2 part on this first one is great for this scenario, but the x minus 3 is in the wrong spot, so that's no good. This one, the x plus 2, it'll cancel in one place, but it stays in the bottom, so it becomes an asymptote. Yeah, and we don't want it to be an asymptote. We want it to be a hole. Okay, so on this one, they would cancel. That'd be great. And the other, this is going to look like 1 over x minus 1, since everything else canceled. So that has an asymptote at x equals 1, and it had a hole at x equals -2. So I think this is going to be our answer. These cancel right here. We have a hole at +2, which is not what we want. It does have an asymptote at -1. Oh, they were just checking to make sure you understood the positive and negatives. There's C is the correct answer. Oh, on this one, they make you factor. If you're not good at factoring, practice. That should be, that should come very easily to you at this point. Okay, I'm not going to do that one. I just don't feel like factoring. I do what I want. Okay, which of the following statements about the graph is true? So what do we notice? This is going to look like, it's going to look like x minus 4 times x plus 3 all over that x minus 2. So it's top heavy, so that means it has a slant asymptote, and it's going to have an asymptote at x equals 2. It's going to have a hole at x equals 4. Okay, so it says it has a vertical asymptote. Nope. It has vertical. It only has the one vertical asymptote at, what did we say, 2? And a hole at x equals 4. Okay. That's fun. Okay, let's see. Same idea here. Let's, how much more does he, he's amazing. Look at all this, you guys. I'm not going to finish this in one video. Let's see for just a second. We'll do 41, and then I might skip some. On this one, okay, so what would this look like? It would look like an x plus 2 stays on the top, and then the x minus 3 is gone. This one's gone, and so it's going to look like that. I don't need the parentheses, but I wrote the top, so I wrote the bottom. But it's going to have it's going to have an asymptote at x equals 3. It's going to have a 0. Oh, it's not going to have, well, it looks like it has a 0 at x equals -2, but it's not, because it has a hole at x equals -2, because that removed itself from the equation. It's removable discontinuity. And so it can't be both a 0 and a hole, or its hole is a 0, but the hole trumps. So let's see. No real zeros, 2 holes. Nope, just 1 hole. No real 0, no holes. Nope, no holes. It has 1 hole and 1 vertical asymptote. So the answer choice is A. Vertical asymptote at x. So these feel pretty similar. I'm going to move on. Still pretty similar. Oh, this is going to make you work a little harder, because you have to actually multiply things out or factor down here or whatever. But it's the same idea. A hole, vertical asymptote, same idea. Hole, vertical asymptote. Nah, we're moving on. Okay. This video is long enough for now. I will come back and keep going right here in just a moment. Like, subscribe, comment below. Let me know how I can help you. Be kind in the comments, because I do read them. All right, go practice.